Welcome friends to SSC CGL Tier 2 level quick algebra problem solving. This is Atanu Chaudhary of SureSolve. Today in this first part, we'll take up the SSC CGL Tier 2 solution set 14 on algebra 5 from suresolve.com and solve its first 5 questions. Let's solve the first of this difficult set of problems. Can you see that with y as inverse of x, the direct expression reduces to sum of inverse of squares like 3x square minus 5xy plus 3y square equal to 3 times x square plus 1 by x square minus 5. And for you, it is easy to evaluate x square plus 1 by x square if you know the value of x plus 1 by x. Just express x square plus 1 by x square as x plus 1 by x whole square minus 2. The direct expression will take the changed form of 3 times x plus 1 by x whole square minus 2 minus 5. The main task is simplified to evaluating x plus 1 by x as an integer from the given expression. The simplest way to do this is to take the direct approach and add the absurd fraction of x with its inverse. You'll get the integer value of x plus 1 by x easily as 24, like x plus 1 by x equal to root 13 plus root 11 divided by root 13 minus root 11 plus root 13 minus root 11 divided by root 13 plus root 11 equal to 24. The denominator of the fraction sum of surds has been just 2, and in the numerator when squares of two surd expressions are added, the surd middle terms are cancelled out to the result of 48. On division by denominator 2, value of x plus 1 by x becomes 24. Now substitute this value in your earlier changed target expression. 3 times 24 square minus 2 minus 5 equal to 3 times 576 minus 2 minus 5 equal to 1722 minus 5 equal to 1717. Answer is option B, 1717. Solved in minimum number of steps. The key concepts and techniques used are direct expression conversion in terms of sum of inverses and direct evaluation of numeric value of sum of inverses from given expression. That's simple. Let's solve the second problem. As the difference of squares of two terms of x is 1, x plus 1 by x will have an integer value without surds. X plus 1 by x equal to 7 plus 4 root 3 plus 1 by 7 plus 4 root 3 equal to 7 plus 4 root 3 plus 7 minus 4 root 3 by rationalization equal to 14. Here we use the key pattern for eliminating surd. To eliminate surd, difference of squares of two terms is to be 1. For x here, 7 square minus 4 root 3 whole square equal to 1. This satisfied the criterion and you accordingly have evaluated x plus 1 by x as an integer without any surd. After getting rid of the surd, now you know you have to convert the direct expression in terms of x plus 1 by x. How easily you do it is the main question. You get the clue when dividing the denominator by x cube, it is converted to x plus 1 by x plus 1 equal to 15. This is the second important pattern discovery that helps you to solve the question in just a few steps more. Naturally, you go on to divide the numerator also by x cube so that no freestanding x remains. 3x to the power 6 plus 2x to the power 4 plus 4x cube plus 2x square plus 3 divided by x cube equal to 3 times x cube plus 1 by x cube plus 2 times x plus 1 by x plus 4 equal to 3 times 14 multiplied by x plus 1 by x whole square minus 3 plus 32 equal to 42 multiplied by 193 plus 32 equal to 8138. Answer is option B, 8138 by 15. The key concepts and techniques used are First pattern discovery for getting rid of the third in x plus 1 by x, and second pattern discovery of conversion of denominator and numerator in terms of x plus 1 by x by dividing them with x cube. The last calculation step couldn't be avoided and it delayed the solution by a bit. Let's solve now the third problem. The interesting pattern that you observe is that both the numerator and the denominator are in fact sum of cubes, but in compound variables, where the sum of the compound variables is 0 in both cases. To simplify dealing with compound variables, first substitute a equal to x square minus y square, b equal to y square minus z square, c equal to z square minus x square, so that the numerator is expressed in compact form as a cube plus b cube plus c cube, where a plus b plus c equal to 0. And then substitute p equal to x minus y, q equal to y minus z, and r equal to z minus x to convert the denominator in compact form as p cube plus q cube plus r cube, where p plus q plus r equal to 0. You have used the dummy variables a, b, c and p, q, r to abstract the two sets of compound variables and brought out the hidden useful relationship of sum of cubes and three variables zero sum. Apply straightaway the zero sum of three variables principle on the numerator and the denominator both and get a cube plus b cube plus c cube equal to 3abc and p cube plus q cube plus r cube equal to 3pqr. On division, the factors x minus y, y minus z and z minus x or pqr cancel out between the two, leaving just x plus y multiplied by y plus z multiplied by z plus x in the numerator. Answer is option C, x plus y multiplied by y plus z multiplied by z plus x. The key concepts and techniques used are pattern discovery of both numerator and denominator to be sum of cubes of compound variables, where sum of compound variables for both are 0, and application of principle of zero sum of three variables. Knowing the three variable zero sum concept and how to use it, the problem could easily be solved in mind. Would you like to know how the principle of zero sum of three variables work? Okay, let's show you quickly how it works. You have a plus b plus c equal to 0, or a plus b whole cube equal to minus c cube, or a cube plus b cube plus c cube equal to minus 3b multiplied by a plus b equal to 3abc, as a plus b equal to minus c. If sum of three variables is 0, then the sum of cubes will be 3 times their product. Let's solve the next problem. To know how you can use the given value of ABC, first simplify the direct expression mentally as c multiplied by a square plus b square plus a multiplied by b square plus c square plus b multiplied by c square plus a square divided by ABC. Now you know by using the similarity increase technique, this is where ABC comes in. And this is the reason why all the choice values have fraction denominator as 3. Next, examine numerator of direct expression more closely to identify that each of a square, b square and c square appears twice in the form of a square multiplied by b plus c plus b square multiplied by c plus a plus c square multiplied by a plus b. Mentally forming the product of a plus b plus c and ab plus bc plus ca, it is easy to see that out of the 9 terms, 3 terms will combine to form 3abc, and the rest will be exactly like the target numerator. So you get the product of two given expressions as 3abc plus a square multiplied by b plus c plus b square multiplied by c plus a plus c square multiplied by a plus b equal to 5 times 7 equal to 35. Value of the target expression is then 35 minus 3abc divided by abc equal to 26 by 3 equal to 82 by 3. Once you discovered that the product of the given expression will result in an expression in terms of numerator of changed target expression, you get the final value quickly and easily. Answer is option B, 82 by 3. The key concepts and techniques used are similarity increase technique to create ABC in target expression and pattern discovery that the product of the two given expressions will generate numerator of the changed target expression. Not a difficult problem at all. Let's solve the last question. To know whether the numerator or the denominator is the larger of the two, the easiest way is to form the difference of the two and compare its value with 0. The difference between the numerator and the denominator is a square plus b square plus c square minus ab plus bc plus ca. Multiply and divide the two by 2. We are going to form a minus b whole square plus b minus c whole square plus c minus a whole square. So we have a square plus b square plus c square minus ab plus bc plus ca equal to half multiplied by 2 times a square plus b square plus c square minus 2 times ab plus bc plus ca. Equal to half multiplied by a minus b whole square plus b minus c whole square plus c minus a whole square greater than 0. Being a sum of squares, the expression will always be greater than 0 as a not equal to b not equal to c. So, a square plus b square plus c square greater than ab plus bc plus ca. Or a square plus b square plus c square divided by ab plus bc plus ca greater than 1 by inequality concepts. Answer is option A, greater than 1. The key concepts and techniques used are converting the problem to a simpler problem of testing whether the difference between the numerator and the denominator is equal to, larger than or smaller than 0, use of principle of zero sum of square expressions and inequality concepts. To read the detailed solutions, refer to the corresponding article in our website suresolve.com. Link is given in the description of this video. And please do subscribe to our channel for latest uploads. Thanks for watching.